Hey, this is Bill Foote, and this is Stats 1, Lecture 6, Part 2B. This is the second half of Part 2. And here we're going to implement Tukey's outlier analysis. Now, what we did in Part A, Part 2A, was build expectations. So those are in the middle of the distribution. What we're going to look at now are, do we have a way of looking at the tails of the distribution? And the Tukey approach from 1977 is an exploratory data and analytical approach. It's based upon very, very simple statistics called order statistics. And those literally look at low, medium, and high levels of rank in the data. And we're going to use percentile as that ranking approach. Now, how do we implement this? Well, the first thing we're going to do, we have two series here in this particular case, Series 1 and Series 2, performance scores across each of 8 performance periods. So if this is GPA, for example, you can imagine that those are 8 semesters, 4 years of undergraduate work, maybe 4 years of graduate work, who knows? 2 different individuals here. So let's first create 2 things here, and you can test this pretty quickly. Oh, there's 2 other things in there. Oh, we don't want them. Here's one. And there's 2. Well, that's kind of interesting. The name manager, let's get rid of these. And I do. Okay, good. And so here's 1. And here's 2. It looks like GPA is a reserved name. And if you try to name something with it, the system will not recognize it. Tried this in a number of places, and thus the anomalies that you might have seen there. What we're going to do here is we're going to put in one of these. 1. And we're going to be referring to the name, which will point to this array. And we have a function that allows us to do that. But let's set up what we're going to do first, which is the min, the 25th percentile, 0.25, the 50th percentile, also known as the median, and the 75th percentile, also known as Q3, the max, the IQR, interquartile range. And if we didn't use quartiles and we used something else other than quartiles, this would otherwise be the interquantile range. Quantiles, quartiles, okay? One's a subset of the other. And we'll have a mean and a standard deviation. I'm just going to use SD for standard deviation. Why? I just don't want to write it out, I guess. That's possible. And here is a set of information that we can derive. Min to the max. And the IQR. And here's another set, which is a little bit different, which is not at all rank ordered. Let's get the average of 1, the first series. And here's how we can do that. Equals average. And we can use a function called the indirect of whatever this name is here. And if it's in the directory of name ranges, hold that. Sit there. Should we close all the parentheses? 2.65. I can copy this down and change the average to standard deviation dot S. Okay, remember we did that with the statistics for GPA a while back, lecture 5. So do check that out. And the reason why we're using S, that's the sample, is we're using up 1 degree of freedom. One of the observation is being used up in making an average, and the average is inside of yet another metric called the standard deviation. Confusing, huh? No, modern statistics. Oh, 76. So let's take the same thing, so just don't have to write it out all the time. Put it up here to the min, the average. We say min. And is it indeed? Yeah, it looks like, yeah, that looks like that's the smallest one. And the max, this. Make sure you change the formula. No, 375. Okay, that also looks good. Always check your results. Now, the 50th percentile, the median, and we could actually use median, but I just would prefer to use this. So let's hijack again one of these phrases here. There we go. Instead of the max, we're going to say percentile of the indirect, but we have to add one more thing. And that is at what percentile? Okay, this will look for the value inside of a series called 1, ONE. It's right in the middle. Let's just, if we ever wanted to copy this to the right, we need to do this. And let's press enter and see what happens. At 255. That number looks familiar. I'll have to. And 2075 is what it's coming up with here. Okay, that's probably more precise than what we had. Not too much more. Down here, 3225. Okay. So those are our numbers for 25th percentile, the 50th, and the 75th. And the IQR is going to be equal to the 75th minus the 25th. We get 1.15. Now, I think we got different numbers because the calculations are done a little bit differently. And there are several ways to do all of these. Now, the way I did it was correct under a set of assumptions. And that was linear interpolation between two numbers. If you really want to do it very precisely, you would use nonlinear. You use a more proportional approach. You're going to get something close enough for most applications. So that's one. What happens if we put 2 in here? Oop, it all changes, as it should. So what happens if I have, 1, 2, 3, 4, 5, 6 of these? It'd be nice to be able to switch out a 1 into the other to be able to do our work. Okay, and we will do that right now. And then after that, we will create the Tukey fences, the lower and the upper bound. Let's do that right now because that's the neat thing to do. So here we have a list of scores. So we have different scores. We have person 1, person 2. That's a list. Give this a name too. Formulas from selection. Now, notice we always want to have exactly that. If we had P-O-O-O, nothing happens. So you get a reference mistake there or error. Oh, there we go. It's back again. Number general. There we go. A little bit easier to read. And formatting. So the human beings can see what you're doing, and you can point to boxes and groupings. There. Okay. Now, we have something called scores now, which is that list. And we're going to apply that list to this cell. The way we do it, this is called data validation. Only certain things are going to be allowed in this cell. We don't want to have to type into this cell because that introduces the possibility of user error, and users don't want to have errors, reasonably so. So in order to do this, we go to data. You have to know where to look for this. I happen to know it's right here. See data validation. So it's in the data tools, right next to the word columns. And it probably is in a different place on a Mac. Press enter. Move this over so we can see what we're doing. And we don't want to put any old value in there. We just want to put something from a list, just like that. Now we could actually put a list in here, but what we want to do is say the source of the list is equal scores. Did I get that right? S-C-O-R-E-S. I did. Okay. Very good. And now you see a little pull down button here for the menu. Creates a menu, and you can change it. In this case, toggling it back and forth. Okay, so that's a very useful Excel tool where we have one set of, we have multiple data, we have a way to compute one set of results, and we want to see one data set at a time. This is the way to do it. So here's the lower bound. And I'm going to write this particular way, equals double quote lower dash. And let's see if this will work for us. Double quote ampersand this whatever value is in there. And see if that works. Oh, it does. Lower 25. Well, actually, I'm going to take it and say that times 100. I'm going to format it a little bit better. Lower 25. Well, actually, I can do one more thing. Do another ampersand, double quotes, percentage, and double quotes. There. That's going to be a little bit easier to read. That's the lower 25. Well, if I got the lower 25, let's take this apparatus, and I don't have to type this all over again, just part of it, and copy it here. Notice it went up to 50. But what we really want is the 6. There we go, the 75. Center, and we want to call this upper. There we go, the upper. And let's format this. Yeah, right, just about, I guess. Whatever the claim was to see. So if I wanted to change things, which I can, make these numbers again. If I wanted to change this to 0.0550, look at that, 5%, and 0.95, I can do that. So I can play with this a little bit. And actually, I can also put those under a list, but I'm not going to do that today. Go back to Tukey. There we go. We have the IQR. Now, this will be equal to 25th percentile minus 1.5 times the IQR, 186. And this will be equal to the 75th percentile plus 1.5 times IQR. And let's put those under a outside box. Well, it's pretty clear that given these, I mean, 4 is the max actually, and we might want to write that the max of whatever the max in the series is, or the min of the max in the series, or this number, whichever is the smallest, so that it bounds it properly. And the same with the lower. We could do that, but I think once again, in this series, we have that didn't work out so well, right? We have an outlier. So is there something less than that here? And the answer is yes. Well, can we count that? The answer to that is also yes. Now let's see if that works. Count if, and it's going to look for a range. And of course, the range is going to be the indirect of whatever is up here, data validated, I might want to copy this formula down. The indirect of anything less than 1.86. There we go. Close parentheses. We have one item that is an outlier. It will be this one, but at least we can get a count of it. And for this one, anything greater than, yeah, there's 8 less than that. That's absolutely correct. Anything greater than F12, we should get 0. Any outliers? Outliers, anybody? We use count ifs to count the outliers. Not to identify them. We have to do that so far by Now, there's a couple of ways that we could do that, which I don't even want to discuss. It's a little bit complicated, but we can eyeball it here. But we should be able to do that. We should be able to say, if it is an outlier, then we can flag it. If we flag it, then we should be able to pull it out and say which one it is and where it is in the series. In this case, it's in row 2 of the series. So probably an index match arrangement can help us find the one outlier. But what if there's more than one? It gets a little bit more. That's where it gets complicated. So what have we done here? Try this. And there are no outliers with the other one, as we had found before. What have we done here? We have 2 named ranges. We found summary statistics, min through max, with different percentiles. These are cumulative percentiles. Very important that these are cumulative. 75% of all the observations are below this number. Less than or equal to 3.23. The max is this. The IQR, the difference between the 75th and the 25th. We have the mean. We have the standard deviation. We have the lower and the upper. John Tukey, 1977, exploratory data analysis fences. And we've also used the COUNTIF to say how many. Do you have, the question is, do you have any outliers, yes or no? And how many? 0 means no. 1 means yes. 2 means yes. And for each one of those. We also did this. We did a data validation on this cell. We did that because we are referring to that cell exactly as an indirect, and we need an exact name, correct one. I mean, if Stubby Fingers did this, it seemed to find it. It should not do that. It did, though. Okay. In which case, it's looking for that, but can't find it because it isn't there. There we go. Sure we have the correct one. And actually, the correct way to do this is to take these 2, select those 2 spaces, and do equals transpose of these 2 names. Close parentheses. Don't do anything yet. Shift, Control, Enter. And now we have complete referential integrity. We have data over here, which nobody's allowed to touch, except certain people under a data governance scheme. We have data validation here, which depends upon, oh, look at that, a one-to-one relationship with the original data. The headers are over here now. Then we have data validation here, and then we just refer to that name because these are stored in the system as thing 1 and thing 2. Okay. Then we did all the stats and outliers in that arena. Great fun. Spreadsheet engineering, data validation, transpose. Use lists and indirect and named ranges, plus min, max, percentile, average standard deviation sample. And we actually constructed that row name using the data in the this whole presentation layer right here. So if we change these, we'll get different approaches here. So if we made this 595, I don't think anything's going to blow up. Didn't. There will be no outliers. So instead of quartiles, we use quantiles. Interquartile range is quite a bit wider. The mean, we still have the same standard deviation, but we have different quantiles, percentiles here. Same min, same max. This still absolutely, it's beyond the pale. But Tukey seems to work well with 25 and 75. And in fact, when we start playing with it like that, it's that take that quantile 25 and subtract from it 1.5 the width of this. 50% of all the observations between 25 and 75. Okay. And how much grade point average is in there here? 0.56. Huh. Start thinking with this. I will leave you with that. That's formatting. And that does it. Take care and enjoy, and happy spreadsheet programming. Thanks.